Rocky, shh.
Hi, everyone. So today we'll be starting our new topic, which is what we call quadratic expressions. Now, that's chapter 11 of your textbook. And if you would be looking at the whole chapter, the focus of that chapter is about factorizing, okay? Now, I don't know if you remember, but when we discussed this in year 8 or in year 9, we said that factorizing is simply the reverse of expanding it, or expanding means multiplying, okay? But there's something special about expanding, as when you say just multiplying. What's so special about that is this operation law, which is our distributive law, okay? It's one of our operation laws. We have the associative and also the commutative laws, but this one here would be what we call the distributive law. What does that tell us? The distributive law tells us that if we have this added to b plus a, if we have a multiplied to b plus c, then we distribute the a to each of the terms here, and the operation would be multiplication. We say that's ab plus ac, right? But when we have quadratic expressions, that means we will have x squared or a squared or anything, any variable raised to the power of 2. Those are what you call quadratic expressions. If you would be doing this, it could either be that a and b would be x squared, and for this one, it's more of two binomials that we want to multiply together. Okay, so really what we want to do here is to apply the distributive law when expanding algebraic expressions. More importantly, when we have two binomials. So maybe we can include that and put them in brackets. That what we want to do here is to expand binomials. These are our success criteria. We know we're successful if we can use the distributive law to expand grouping symbols, expand expressions using the distributive law, explain how multiplication of binomials work using areas of rectangles. Okay, and that's why for our warm-up today, we've got here some rectangles, and hopefully you'll be able to understand why when we multiply two binomials, that is the answer. Okay, so it's really for us to have an idea what happens when we multiply two binomials. Okay, and just like in learning any maths, we start with what we know, right, and then build from there. Just like this square here, we know it's a square because the length of this is equal to that length. If we are to figure out the area of that square, then that's simply a times a, which is equal to a squared. Yeah. Now, what if this time we've got this, we still have that same square here, but what if we say we expanded that land, right? And we say, well, we could add that length of 3 here on this side, and we could add a length of 2 here on this side. And now this becomes our rectangle, wherein one side is a plus 3, and then the other one is a plus 2, right? And similar to what we did previously, what we did was to just multiply the 2 dimensions, so that if I have to calculate the area of this rectangle here, I would have a plus 3 multiplied by a plus 2. Yeah. Now, what is that equal to? Well, maybe what we could look at, just like when we were learning about composite shapes, we could say, well, we can make the problem simpler by dividing them into simple shapes, just like what they did here. You have here, this is the area, our original area, which is A1. We could say that that part there is A2, this one is A3, and this one is A4. And for us to figure out the area, the total area, we just simply add all the answers. Now, how do we get the area of this square here? It's a times a squared, which is what we did here, which is a squared there. What is the area of this rectangle here? Well, for us to figure out the area of any rectangles, we go 3 times the length times the width, or width times the length, whichever one you want as the length or the width. This one is 3 times A, which is simply 3A, right? This rectangle here would be 2 times A, and therefore that's equal to 2A, right? This rectangle here would have dimensions 3 multiplied by 2, and therefore that's equal to 6. And what did we say a while ago that we will be doing with those areas? We simply put them together. And if we write them down, what did we notice about these two terms here? That we can combine them, right? We can combine them because they are like terms. What's 3A plus 2A? That's equal to 5A. And therefore, we've got A squared plus 5A plus 6 as the area of this new rectangle here. Okay, now let's ignore this for a moment. We'll go back to that in a second. Okay, now if that is adding a length of 3 and this one adding it to 2, what if this time it's not adding it, but we want to get rid of some of that area there, right? We can still do that. And what we want to figure out, maybe I need to, what color? Maybe red. This time we want to figure out what is the area of this shape here without the shaded region that we have here, right? Now, how do we figure that out? It would still be what? What's the length times the width? Well, it's not A anymore, but it's A minus 2. And then this bit here would be A plus 3. Yeah? So for us to figure out the area of each of these rectangles, well, this one here, this whole thing here is A squared, right? And then what do we have here? This one is, let's imagine that's still the whole length A, right? So this is A multiplied by 3, and therefore that's 3A. But then we don't want the whole area here. We don't want to get, we want to get rid of this bit here. And what would be the area of this? That would be what? That's 2 multiplied by A, and that's 2A. This one here that was shaded that we want to get rid of, that's 2 times 3, which is 6. But it's getting rid of it, so you're taking it out of the whole area. And if it's taking out, if you're getting rid of it, it's a minus. So minus 2A and then minus 6. Yeah. And still, you have your two middle terms here as like terms, and therefore you could combine them and you will get A squared plus A minus 6. Your 3A minus 2A becomes 6. Does that make sense? So what are these boxes for? You've got here, this is what you call the box method. So what you do, you don't have to draw it to scale, and you say this is A plus 3, A plus 2. How do we calculate the product, or when we multiply A plus 3 and A plus 2, what do we get? Well, you just do it as A times A, you get A squared. 3 times A, you get 3A. A times 2, you get 2A. And 2 times 3, you get 6. And since you would be able to combine these two terms here, you can just say that's equal to A squared plus 5A plus 6, which is the same as what we got there. Okay, so you don't have to draw a perfectly looking squares or rectangles. Okay, so again, even if it's a minus, you don't have to draw that it's taking out or getting rid of that bit of the shape. You can just say just draw a 4-window shape, and you have a minus 2 on one side, a plus 3 on the other. What is a times a equal to? That's equal to a squared. What is negative 2 times a equal to? That's negative 2a. A times 3 is 3a. And then negative 2 times 3, you get negative 6. And again, you have these two that you can combine, and therefore you've got a squared minus, what's 3a minus 2a? That's equal to plus a, and then minus 6. Okay, so let's probably try with a few other examples that you've got there in your book. The first one is x plus 3, x minus 4. So what we want to do, you want to multiply these two binomials here. What we said, we can draw a 4-box window here, and we say that's x, that's 3, this is x minus 4. Okay, so you just need to make sure that you multiply your negatives correctly. What's x times x equal to? That's x squared. What's 3 times x equal to? That's 3x. And then what's x times negative 4 equal to? That's negative 4x. And then x negative 4 times 3, you get negative 12. Okay, so again, you have these two here, which you can combine, and you could say straight away that our answer is x squared. What's negative 4x plus 3x? It's minus x, and then minus 12. That was question 2A of your textbook. Okay, if I were to do question 2B, they've got it as x plus 1, x minus 3. And if I draw a window there, x plus 1. And this one is, oops, that's x minus 3. And what's x times x equal to? That's x squared. X times 1 is 1x, or simply x. X times negative 3 is negative 3x. And negative 3 times 1, you get negative 3, right? And again, you can combine these two. You have x squared minus 2x minus 3, because then minus 3x plus x is minus 2x. Okay. Now, if you didn't like this method here, you've got another strategy that the textbook discusses, which is probably what you've seen in year 9 as well, which is what we call the FOIL method. Okay, what does FOIL stand for? FOIL, F stands for first terms, outer terms for O, and then inner terms I, and then last terms L. Okay, what do we mean? If we were to do the 2 questions that we just did a while ago from your textbook, 2A, that is x plus 3 multiplied by x minus 4. You would have what? First terms. That's the first terms, right? And therefore you would multiply them two. You get x squared. The outer terms, that's this and that, because they're outermost, right? And therefore you've got x times negative 4, you get minus 4x. The inner terms, you've got 3 times x, right? That's plus 3x. And then the last terms would be 3 times negative 4, which is negative 12. Okay, now some textbooks might call this the parrot's beak. It does look like a parrot's beak, right? Or whatever they call it. It's really just expanding that binomial, right? And again, we have these two middle terms here, which we can combine and say they are x squared minus x minus 12, which is supposedly what we got here as well, x squared minus x minus 12. Yeah. We can do that with question B. Our question B was x plus 1, x minus 3. So again, FOIL method or parrot's beak, we go first terms, that's x squared. Outer terms, we've got negative 3x. Inner terms, we get x. And last terms, we get negative 3. And combining these two, you get x squared minus 2x minus 3, right? Which is what we got here as well. Okay, so two methods of doing it, whichever one you want or appeals to you most, and a strategy that you will be able to remember, right? And then when you actually practice them, do them more often, you could probably just do them in your head. Okay, the same thing with the examples that was discussed in your textbook. You've got there x plus 3 multiplied by x plus 2. So you simply write them down first. It helps when you write them down, just like what we did a while ago. And then you have your first terms, outer terms, inner terms, and then last terms. And then you simply combine the two middle terms, 2x and 3x, gives you 5x. This one here, you can't combine anymore because all these terms are unlike terms. That's the simplified form when you multiply these two binomials, okay? Now, the second example would just be showing you the one wherein you've got there a tricky bit there, a binomial here, because normally you have x plus something, right? But this one, they've inverted them, right? It would simply be the same, right? So you've got there your first terms, x times 6, which is 6x. Outer terms, x times negative x, which is negative x squared. Inner terms is negative 7 times 6, which is negative 42. And then you've got negative 7 times negative x, which is positive 7x, okay? And you would have to look for the ones that are like terms, which are like terms here. You've got 6x and 7x. If we combine them, you get 13x. So you've got minus x squared plus 13x minus 42, okay? Now, another way to do that so that it looks like the ones that we've been doing a while ago is for you to actually swap these around. But when you do swap them around, just remember that it's negative x plus 6. What do I mean? So we could rewrite this as x minus 7, and that one would be negative x plus 6, right? So that when you multiply, you would have what? First terms, that's negative x squared. Outer terms, you've got 6x. Inner terms, you've got negative 7 times by negative x, you get positive 7x. Negative 7 times 6, you get 42. I mean minus 42. And therefore, we can combine these two. We end up with negative x squared plus 13x minus 42, which should be just the same as what we have here. Now, once you've maybe finished the first two questions of your exercise, you could probably have a look at the exercise in question 3. So they would look like these ones here. This one here that you've got as your example number 2. What's the same, what's different from what we were doing a while ago? Well, this one here, that's really just the binomial times the binomial, but the added one there would just be the 3, right? So what could be a sensible thing to do? Well, we already know how to multiply the expansion here, or multiply the binomials here. And then what we need to do is later on multiply by 3, whatever is the answer. Okay, just like what they did here, they used the FOIL method first to calculate what's x plus 8 times x plus 2, which they got as x squared plus 10x plus 16. And then they multiplied 3 to each of them, and they get 3x squared plus 30x plus 48. Okay, So if we would be looking at the last two examples, examples 3 and 4, these are what you call your special products, okay? What's so special about them? Well, this one says 2x minus 5, and the whole thing is squared, okay? So the title of that is squaring a binomial, right? Now, what do we know about a number when it's squared? Then it's simply using this binomial as a factor. How many times? 2 times, right? What do I mean? It means that if we have 2x plus 5, minus 5, and when we square that, that simply means it's 2x minus 5 multiplied by itself, right? And you can truly use the same method as what we were doing a while ago. You can do the box method if we would be doing the box method, just to maybe just review what was that a while ago. We've got 2x here and then minus 5 here. We've got 2x here, minus 5 there, right? And what's 2x times 2x? That's 4x squared. 2x times negative 5, you get negative 10x. 2x times negative 5, the same thing, negative 10x. Negative 5 times negative 5, you get 25. What did we notice here? We can combine them and say that's equal to 4x squared. Negative 10x plus negative 10x is negative 20x, and then plus 25, right? And that's the one that they got here as well, okay? And for sure, you'd be able to use your FOIL method and you'll be able to get the same answer, right? Now, what's added here, what's that extra bit there that they've done, is, aside from squaring this binomial, whatever is the answer, you multiply by negative 3, right? And you should get this as the answer. So you can try that using the box method. You can also try that using the FOIL method, right? And then multiply negative 3, whatever is your answer. Now, what do I want you to notice here is that when you have squaring a binomial, it's you square the first term, that's 4x squared. You square the second term, you get 25. But it's not simply 4x squared plus 25. You have a middle term. How do you get the middle term? If you multiply 2x and negative 5, you get negative 10x, which is what we got here. But how many lots of negative 10x's do we have? We have 2. So then you have here, your middle term is negative 20x, okay? The same thing when you multiply 2x plus 7. And if you want to square that, you say the first terms would be 4x squared. The last terms would be the square of this, which is 49, right? But what's the middle term? The middle term would be 2x times 7, which is 14x. And if you will be using the box method, you'll notice that it's 2 lots of 14x's, and that becomes 28x, right? Which is what they've got here, 4x squared plus 28x plus 49 is that, okay? And then afterwards, you multiply by negative 3, and therefore you get negative 12x squared minus 84 minus 147, okay? Now, if you would be looking at the example 3 and example 4, what's the same, what's different? Well, this one is 2x minus 5 times 2x minus 5. This one is 3x plus 1. It's not multiplied by 3x plus 1. It's not squaring it. But what you want to do is to multiply it by 3x minus 1. So the first terms and the last terms are the same, right? But look at the symbols here. That's plus, that's minus. The same thing as this one. That's 2x, 2x, 7, 7. But what's different is that this is minus and that's plus. Okay, now this is what you call your difference of 2 squares, because that's the difference of 2 squares, right? What's the square of 3x? It's 9x squared. What's the square of 1? It's 1, okay? Why did we not have a middle term? Because they cancel out each other, okay? If I were to do the box method for that one, I have 3x plus 1, 3x minus 1. I have 9x squared. That's 3x here. That's minus 3x. And that's minus 1. And what did we notice here? They cancel out each other. They're opposites, right? So that's positive 3 minus 3, you get 0. And therefore, you only have 9x squared minus 1 as your result for multiplying 3x plus 1 and 3x minus 1. Okay, and again, with our second example here, what's added there is that after you get the answer, you multiply it by 4. Okay, so the same thing with this one. You've got, what's the square of 2x? It's 4x squared. What's the square of 7? Is 49, and it's minus 49 for your second term. And then you multiply by 4, you get this as your answer. Okay, so what I want you to do for your exercises is to complete questions 1 to 13. You don't have to do all of them. Maybe do the first or the second columns. All right, and then move on to the more difficult ones. You'll have in questions 8 and 9, those are similar to your work example 3. And then question 10, that would be similar to this example here. So always go back to your example for you to be able to do your work, okay? And if you've got any questions, you're free to message me, okay? All right, see you all next lesson. Bye.
Come on, Rocky, let's go.